Oh.
Okay.
Oh, should we?
So, let's start with yesterday's and see how much you guys can recall. Let's say just the money part though. Let's say I invest $1,200 at 3.4% interest for compounded quarterly for like 3 years. How would I figure out how much money I would have? Okay. What was I'm trying to see how much of the formula you remember. Okay, what would I write?
1,200
Parentheses.
1 plus 0.034
Good, yeah, that's good. Yeah, the formula. So here's the formula they were using. It was P is the initial amount, it's called the principal. You do, trying to move out of the way a little bit. 1 plus the interest rate over K, where K stands for that amount of times it's compounded per year. Quarterly means 4 times a year. So that's where this 4 and that 4 came from, and the T stands for, we're doing time, how many years? We're doing pretty much the same thing as that, but it's not about money today. I think there are a couple money problems, but it's just about anything. Because these exponential growth formulas don't just apply to money, they apply to anything that grows exponentially. Like maybe the value, value's kind of money too. Population growth or something like that, or the school population could grow, or shrink. There's actually some shrinking too. Anyway, we'll chat about it. Let's look at number 1. Not much. There's not much to do now. Okay. So there's number 1. What do you think the 20? I'm going to use this to explain what it is. What do you think the 20 is? It's like the P. So initial amount. That's like the starting amount. Okay. The only difference is P means principal, which means money, and we're not really talking about money necessarily. So they just call it the initial amount. What do you think the 3/10 is? It's like the rate. So I don't know if you guys remember, but I also had the simple interest, which was like this. There was no K compound. So this is like the interest rate, but since we're not talking about money, now it's the percent change. Okay, it's not now they didn't write it as a percent, but we're going to have to write it as a percent. It's a percent change. Do you guys know what 3/10 is as a percent? 3 divided by 10 equals 0.3, which equals, move the decimal twice, 30%. Okay, so that's like a 30% drop. What if I did 1 minus 3/10? What would that give me? What is 1 minus 3/10? 7/10. So, or you could say 1 minus 0.3 is 0.7. Or you can use a decimal order fraction. 7/10 or 7/10, same thing. Okay, so this is kind of like the simplified version. Most of these today will actually look like this. So when they write it separate, this is the percent change. But if they simplify the parentheses, they call this the growth factor. Okay, the growth factor, you guys know what a factor is? it's a number that you multiply by. So 20 is going to be multiplied by 0.7 x times. Like we're going to do 20 times 0.7 times 0.7 times however many, whatever the exponent is, right? So that's why they call it the growth factor. What happens when you multiply 20 times 0.7? What's going to happen to that number? It's going to get smaller. When you multiply by a value that's less than 1, it's actually going to get smaller. When you multiply by a value larger than 1, it's going to get bigger. So when you subtract 3/10 or 30%, what your value is going to drop by 30%. So your value is only going to be 70% of what it was. So after 1 year, 0.7 times 20 is like 14, after 1x, whatever x stands for. And then if we multiply by x again, or sorry, by 0.7 again, it would be, oh, that's kind of messy, it would be like 9.8. Okay, so it just keeps dropping and dropping and dropping. So if this value in the parentheses is less than 1, it's actually going to be not an exponential growth, it's going to be a decay. Kind of like those graphs we did yesterday where they went down. So this is exponential decay, and then yesterday we also graphed exponential growth. So if the value inside the parentheses is greater than 1, it's going to make it grow, and yeah, that's called growth, exponential growth. Okay, so there are 4 questions on each of these. It doesn't take very long. Question number 1, we kind of answered all the questions already, but what is the initial amount? So that's the one they put out in front, it's the 20. Question number 2, and this is the trickiest one because they want a percent. What is the percent change? Right, it's dropping by 3/10, which is like 0.3. If you're not sure what it is as a decimal, just like plug in 3 divided by 2. That's 0.3. And to change a decimal back into a percent, go the opposite direction, it's 30%. The decimal goes over here, a 0 goes in that spot. Okay, but because it's dropping by 30%, we need to put a negative 30%. Okay, and then the third question is, what is the growth factor? Which means when you simplify this, the 1 minus the percent change, what growth factor is just what the parentheses simplify to. Which most of the time they automatically do that, but that would be 0.7. Okay, so that one's not a percent, it's like 70%, but we're not going to write it as a percent. Either a decimal or a fraction. Either one. And the last question is this problem represent a growth or decay situation? Decay. Basically, if that's a minus, or if this value is less than 1, it's going to get smaller, so it's decay. If this number was a plus, or if the value is greater than 1, that means it's going to grow, it's growth. And that's all, those 4 answers. So no, there's not really work to show. I did a little bit of work kind of but no, there's not really any work. Number 3. Y equals 42, 1.5x. Okay, so this one, as most of them are, they already simplified the parentheses. So we gotta kind of figure out what happened there. What's the initial amount? Let's start with the easy one. 42, okay. So the second question is, what is the percent change? Okay, so what must they have done to the 1 to turn it into 1.5? They must have added 0.5. Like this is the question. What must they have done to the 1? What must this have been to turn it into 1.5? Well, R must have been 0.5, right? Because 1 plus 0.5 is 1.5. So the rate of growth is 0.5. What is 0.5 as a percent? What's the percent change? 50%. You just move the decimal twice over. So it'd just be 50%. Okay, what is the growth factor? 1.5, it's just the thing in parentheses, it's already simplified. Does this represent a growth or decay? Growth. Okay, number 5. 1/2 to the t. On number 4, there is no number in front of the parentheses. So what number do you think is in front of the parentheses? 1. Because 1 times anything is just the same. So that's like an invisible 1 there. All right, number 5. 1/2 times 1/2 to the t. Okay, what is the initial amount? Half. Sorry, are they doing presentations over there? You just don't know. Okay, the second question is what is the percent change? So what did they do to the 1 to get it down to 1/2? They must have done 1 minus 1/2, right? Or 1 minus 0.5. So the percent change is like the minus 1/2 part. What is 1/2? Well, as a decimal, it's 0.5, right? So what is that as a percent? 50%. So yeah, it's going to be negative 50%. If something is dropping by 50%, it's only going to be half of what it was, right? That's where that comes from. Okay. What is the growth factor? The thing in parentheses, so it's 1/2 again. If you put 0.5, it's not wrong, but I just usually copy whatever they put. What was the last question? Is this an example of growth or decay? Decay. Because the growth factor is less than 1, or we've got a negative percent change. Is that 10,000? Okay, so on 7, what's the initial amount? 10,000. Okay. Oh yeah. What's the percent change? How do you get from a 1 to a 0.975? Yeah. Well, if you're not sure, you could just subtract to see how much it's changing by. 1 minus 0.975 comes out as 0.025. So the 1 must be dropping by 0.025, right? So what is 0.025 as a percent? Right. Move the decimal over, that's only 2.5%. Is that a positive or negative?
Negative.
It's negative because it's dropping down to that. So negative 2.5%. What was the next question? Oh, what's the growth factor? Thing in parentheses. Factor because it's a number that keeps getting multiplied over and over again. And is this an example of growth or decay? Okay, so number 9, they're kind of applying these to like real situations. So we're supposed to write the formula. So our answers will kind of look like the questions on 1 through 8. And I'm just going to call all these like f of t. So I'm going to use function notation. And write the function. So it says, number 9, a $33,000 car is expected to lose 1/6 of its value each year. So we're supposed to model the car losing its value, 1/6 of its value every year. So what am I going to start with? 33,000. Okay, then comes the parentheses. So it's supposed to lose 1/6 of its value. 1 minus 1/6. Okay, let's go ahead and simplify that though. What is 1 minus 1/6? If you have one cookie and you eat 1/6 of the cookie, what are you left with? 5/6. So let's just do the simplified version there. So that means after 1 year, the $33,000 car is only going to be 5/6 of what it was the next year. And then 5/6 of that the year following. So they didn't tell us how many years, so we just put a T right there. But then if you keep reading the directions, it says find f of 5 and f of 12. Well, what does f of 5 mean in context of this problem? Huh? Okay, you plug in 5 for t, but what does it mean? What does that tell us? 5 years what? Okay, it tells us the value of this car after 5 years. Okay, so you guys, you just need to plug in 5 for t and that will give it. And they also ask for f of 12. There's nothing special about these two numbers. They just chose them randomly, basically. That's just what the directions told us to do. So f of 12 tells us how much your car would be worth after 12 years. The value of a car is like exponential decay. Like right as you buy it, the price starts dropping quickly, and after a while, it's not worth very much. All right, I'll let you guys plug that in. Let's keep going. We're talking about money, so we went around to the nearest cent, which is the second decimal place, right? On these two. Number 11. A telecommunications company plans to expand its workforce of 220 employees by 3% each year. So we're starting out with 220 employees. So I'm going to do f of t equals 220. Okay, how do I increase that amount by 3%? One plus, what's 3% as a decimal? Point. So the decimal, the invisible decimal is at the end of the 3, so move it twice, 0.03. Yeah, so in the parentheses, I'm just going to put 1.03. And then for t years. Okay, and then don't forget to find f of 5 and f of 12. Okay, they kind of snuck this one in here on me. Maybe they do. Half-life. Have you guys heard of half-life in science? Don't make me explain it, please. No. Okay, you haven't heard of it, I guess. The other class said they did it like once, but the other class is like juniors, so something to look for. Oh, you've heard of it? You took chemistry too. Okay, half-life means
Just have Ava explain it. I don't think I could.
It's okay. Well, it's usually used for, I think like, what's the word I'm using?
Bacteria.
Well, I wasn't gonna say bacteria. I was gonna say radiation. It's usually used for like radiation. Well, maybe it could be used for bacteria too, but it's for stuff that's dying off though.
Yeah.
The half-life of something is like how many years or minutes or months before it's half.
Find that it takes for half of the radioactive isotopes decaying to stabilize to another element.
Okay, yeah. So it's usually used for radioactivity. It's how long? How many years does it take before half of this stuff goes away? Half of the radioactivity or whatever goes away. So if the half-life of have you guys heard of Chernobyl? There was a power plant in Eastern Europe, and they screwed up. I feel like it might have been Ukraine even.
It was like on the border of Ukraine, and I forgot the like.
Anyway, they screwed up and it blew up, and there's a radioactive area that nobody lives in now. But like every 1,000 years, it's only going to be half as bad as it was. Like it kind of radioactivity wears down or something. So the half-life of that would be like 1,000 years. Like it's going to be half as bad as it was 1,000 years later. I don't know exactly. That's roughly what it would. But half-life is like closely related to this. So for a half-life formula, you still have your starting amount, and then it's only going to be half of what it was. Like 1/2 is the growth factor. But it's half of what it was. Instead of every t years, it's t years divided by h, where h is the half-life. Because if the half-life is, let's say, 1,000, for example, you need the time to get up to 1,000 before you would take half of whatever the amount was. Anyway, this is the formula. That's how it works. Only number 13 is like this, so you're going to have to just relearn it when you take chemistry again, I guess. It's not a terribly complex formula. It's just slightly different than what we've been doing. So on 13 it says the amount of 50 grams of an isotope. So 50 grams is what we're starting with. And for half-life, it's always going to be half of what it was. The half-life for this isotope is 8 minutes. So the 8 is going to go where I put the H. And then T is the variable, like how many minutes after this. So this is something that like degrades rapidly. Isotope. What's an isotope? I don't remember. Ava, isotope.
There's like different things that start with I.
There's lots of I words.
There's a lot of
Okay.
I words.
Isn't it like a simple mutation?
Well, it's been a while since I took science, so I don't really remember either. So, let's see.
More isotopes, more biology anyway. Maybe. Yeah, physical science.
Physical science.
I know we've talked about them, I just wasn't paying attention.
Ava, jeez.
I
Okay.
learned it all like when I need it, to be honest.
For the test, and then you forget immediately after. What if you decide to go into like biology or something?
Can you relearn it then?
I would fail biology if I did it again.
Okay, you have to relearn it, I guess.
Maybe biology too.
No, when I said go into biology, I mean like as a career. Anyways, I forgot what I was doing. Oh yeah, that's pretty much it. We just have to find f of 5 and f of 12. So just plug those in. Bro. Okay, am I forgetting something?
we don't have homework today.
No, that doesn't sound like me.